Today, I want to connect three ideas that are often discussed separately: how we travel, how green products are designed and measured, and how global competition shapes the clean transition. If we want a carbon free future, we need to cut emissions from transport. That matters because climate action is not only about power stations and heavy industry. It is also about millions of small daily decisions: how we commute, how we shop, and how we move around our cities. At the same time, many climate solutions disappoint because we focus on what happens on the street and ignore what happens in factories, supply chains, and waste streams. So we must think in terms of life cycle emissions, not only what comes out an exhaust pipe. Finally, the clean transition is now also a global business story. China's companies are becoming more competitive. A generational leadership shift is changing how they innovate, and electric vehicles are moving from niche to mainstream. When we add Chinese electric vehicles to the picture, we see both promise and tension at once. EVs can reduce emissions, but cheaper EVs also intensify competition and trigger political and trade conflict in Europe and the United States. This speech explains how these pieces fit together, why the transition is not just technical, and why practical climate progress requires good design, honest accounting, and realistic policy choices. Let's begin with the most direct lever: driving less, especially for short trips. Many car journeys are short, often under 5 miles, which is important because short trips are easy to replace if cities make alternatives safe and convenient. Short trips can also be disproportionately inefficient, especially in stop-start traffic and cold starts. This is where micromobility, e-bikes, and e-scooters comes in. The basic idea is straightforward. Smaller vehicles use far less energy, so the emissions per trip can be dramatically lower than a car trip of the same distance. Even if you do not memorize any single statistic, the direction is clear. Lighter vehicles, shorter trips, and share fleets can reduce emissions quickly. The point, however, is not to treat scooters as a gadget trend. The point is to redesign what becomes the default for everyday movement. When walking, cycling, and micromobility feel normal and safe, people naturally drive less. When fewer people drive, buses run more reliably, roads are less congested, and cities become easier to move around without a car. Once driving becomes the exception rather than the habit, it also becomes much easier to decarbonize what remains. In that sense, micromobility is not a niche. It is a system tool that can replace millions of small car trips with something cleaner, cheaper, and often faster. However, there's a trap. A company can claim its service is green, while quietly shifting environmental costs elsewhere. If we only look at what happens during use and ignore what happens upstream, we can end up celebrating solutions that simply move emissions around. That is why life cycle thinking matters. If a product is made cheaply, used briefly, and discarded quickly, then emissions are not avoided. They are front-loaded into manufacturing, shipping, and replacement. A useful example is early shared scooters that reportedly lasted only about a month. If products break quickly, the climate footprint is dominated by production and constant replacement, not by riding. The climate case improves dramatically when products are built to last and designed to be repaired. Durable design is not a minor engineering detail. It determines whether a service is genuinely low carbon or just fashionable and wasteful. Longer product life means fewer new units, fewer deliveries, fewer repairs that require entire replacements, and less material ending up as waste. The same logic applies to batteries. Swappable batteries can keep vehicles in service longer and reduce the number of servicing trips needed to recharge or maintain a fleet. Extending battery life and managing batteries responsibly at the end of their first use also matters, because batteries contain valuable materials and require energy to produce. The core lesson is simple. Climate progress is not only about changing what people do, it is also about changing how companies design, maintain, and retire the products we rely on. Now let's bring in electric vehicles. EVs are often presented as the main route to cleaner transport, and there's a solid technical reason for that. Electric motors are highly efficient, and they replace the combustion process that produces direct tailpipe emissions. If the electricity used for charging comes increasingly from low-carbon sources, the emissions per kilometer fall sharply. But the key question is still life cycle impact. EVs often have higher production emissions than petrol cars because battery manufacturing is energy intensive and materials extraction and processing can be carbon heavy. The issue is what happens over the full lifespan, how long the vehicle lasts, how much it is driven, how clean the electricity supply is, and how the battery is managed over time. In many settings, the life cycle evidence indicates that battery electric cars can deliver significantly lower greenhouse gas emissions than comparable petrol cars, and the advantage grows as grids decarbonize. So the climate argument for EVs is real, but it is not magic. EVs work best as part of a broader system. Cleaner electricity, durable products, good charging infrastructure, and sensible travel patterns. That last point matters because even a clean car still takes up road space, contributes to congestion, and requires resources to build. The real goal is not replace every petrol car with an EV and keep everything else the same. The goal is reduce car dependence where possible and electrify the trips we still need. At this point, it helps to widen the lens from technology to industry. A major change is underway in how Chinese companies compete. Many are going through leadership transition as founders hand over to a younger generation described as globally educated, internet native, and often multilingual. In mid-sized firms, this shift can be especially powerful. They are large enough to scale, but still nimble enough to change quickly. The broader prediction is a move in three directions: less imitation and more innovation, more disciplined, investor-style decision-making, and shift from selling single products to building full ecosystems. Whether every case fits perfectly is less important than the general pattern. Intense domestic competition pushes rapid iteration, better product design, and faster learning cycles. This matters for EVs because electric vehicles are not just cars with batteries. They are part of an ecosystem that includes software, power electronics, battery supply chains, charging, maintenance, and after-sale services. Companies that understand ecosystems can cut costs faster, improve user experience faster, and scale faster. In climate terms, that can be positive. Better product at lower prices can speed adoption, and faster adoption can reduce emissions sooner, especially if electricity generation is becoming cleaner at the same time. But that same speed also creates tension. When one region's firms become highly competitive, other regions worry about losing industry, jobs, and strategic capability. So business change and climate change are now linked. Competition can accelerate progress, but it can also trigger political backlash. This takes us to the uncomfortable part. Cheap EVs are not only a climate story, they are also a trade and industrial policy story. In Europe, policymakers have raised concerns about unfair advantages and have taken measures that increase the cost of importing certain electric vehicles. In the United States, the approach has been even more restrictive, using tariffs and other tools to limit the market access of Chinese-made EVs. Whatever your view on these policies, the message is clear. Governments are trying to protect domestic auto industries while they scale their own EV transition. This is why the EV debate can feel confusing. On one day, everyone agrees that emissions must fall quickly. On the next day, governments argue about which companies get to sell the vehicles, where those vehicles should be built, and who controls batteries and critical materials. Both positions can seem rational from different angles. Climate policy pushes for speed and widespread adoption. Industrial policy pushes for domestic capacity, supply chain security, and political stability. The challenge is that these goals can collide. If trade barriers slow down EV adoption, emissions stay higher for longer. But if domestic industries are overwhelmed and lose jobs rapidly, public support for climate policy can weaken, and the transition can stall politically. So the real problem is not only which technology is best, it is how do we design rules that deliver emissions cuts while keeping transition economically and politically sustainable. So how do we square the circle? We start by being honest about objectives. If the only goal is the lowest consumer price, cheaper imports look attractive. If the goals include domestic jobs, domestic manufacturing capability, and strategic control of key supply chains, dependence on foreign producers feels risky. A practical response is to accept that global competition will continue, and then shape it. Competitive firms can adapt to barriers by localizing production, partnering with local suppliers, investing in service networks, and tailoring product ranges to local regulations and consumer preferences. None of that is mysterious. It is standard behavior in global industries when market access becomes politically sensitive. The climate perspective, however, adds urgency. We want EV adoption to move quickly because transport emissions are high, but speed without social stability is fragile. People who feel that the transition threatens their livelihoods are less likely to support the policies needed to finish it. That is why a credible transition needs a just transition logic, not only a technical plan. A workable compromise can look like this. Set clear emission standards. Invest in workforce training and regional industrial renewal. Support domestic innovation, and allow competition under transparent rules that discourage dumping and reward real efficiency. That way, markets still move toward lower emissions, but the transition does not become a political shock that triggers permanent backlash. The aim is progress that lasts. Now let's return to a grounded principle that applies across technologies. Reduce, reuse, recycle, but do it in ways that genuinely cut emissions. Product design can transform a climate footprint. A durable, reparable product spreads manufacturing emissions over many years of use. A disposable product concentrates them into a short window and creates constant replacement cycles. That logic applies to micromobility, and it applies to EVs. An EV's climate impact depends heavily on its battery life cycle. How the battery is produced, how long it remains useful, how it is maintained, and what happens at end of life. Battery management is not a side issue. It shapes costs, consumer confidence, and sustainability. This is where policy and industry standards can help. Right to repair rules, clearer information about battery health, and robust recycling requirements can reduce waste and support second-hand markets. Companies can design components to be replaced and repaired rather than forcing full replacement, and they can plan for battery reuse and recycling so materials remain in the system. Consumers also influence outcomes by valuing durability and repairability, rather than assuming that the cheapest option is always the best. The clean transition must not become a new version of fast fashion. Low prices, rapid replacement, and mountains of waste. If that happens, we shift emissions around rather than reducing them. The more we build systems that keep vehicles, scooters, bikes, and cars in service longer, the more we lower emissions per trip, per kilometer, and per year. Putting it all together, we can outline a realistic pathway. Step 1 is mode shift. Replace as many short car trips as possible with walking, cycling, public transport, and micromobility. This cuts emissions quickly and improves city mobility at the same time. Step 2 is electrification. For trips that still require cars, move from petrol and diesel to electric, because EVs can reduce emissions, especially as electricity generation becomes cleaner. Step 3 is life cycle discipline. Design vehicles and batteries for long life, easy repair, and responsible end-of-life handling. Step 4 is industrial realism. except that the clean transition is also a competition among firms and regions. Competitive Chinese EVs can accelerate adoption by lowering prices and improving products, but they also provoke defensive responses from governments and incumbent industries. If that tension is managed poorly, we get slower adoption, higher emissions for longer, and rising political resentment. If it is managed well, we get faster emissions cuts and healthier long-term industries in more than one region. That is the real prize, not one winner, but a global shift toward cleaner mobility that is stable enough to endure. Climate progress requires both technical change and social legitimacy. It needs infrastructure, pricing standards, and industry strategy to point in the same direction. When those pieces align, the transition becomes easier. When they fight each other, progress slows and trust breaks down. So, what should we take away from this discussion of travel behavior, life cycle design, and global competition around Chinese EVs? First, emissions fall fastest when we reduce unnecessary car travel. The cleanest trip is often the one that does not require a car at all. Second, green must be measured honestly across life cycles, not claimed through slogans. Third, the transition is shaped by corporate strategy and generational change. Newer firms can innovate quickly, cut costs quickly, and build ecosystems that make adoption easier. Fourth, trade conflict is not a sideshow. It is part of the transition because governments want to protect domestic industries while pursuing climate goals. The only workable approach is to stack solutions. Fewer car trips, more electrification, cleaner electricity, durable products, and clear rules for competition. If we do that, we can reduce emissions without pretending politics will vanish. We can also build a future where clean mobility is not a sacrifice, but practical improvement, something people choose because it is convenient, affordable, and reliable. The transition will not succeed by technology alone, and it will not succeed by protectionism alone. It will succeed when everyday travel becomes easier without a car, when electric vehicles are genuinely cleaner across their life cycle, and when the economic changes of transition are managed in ways that keep public support. That is the challenge and also the opportunity of the next decade.